Okay, binary to decimal. So binary to decimal by Watsushi. Implement binary to decimal, which takes an exact string type S consisting of 0 and 1 and returns an exact number type corresponding with S when S is regarded as binary. You can assume that the length of S is equal to or less than 8 and S is not empty. By the way, in this type challenges video series, we don't use S just because, like, why? I just use T everywhere. You can use S. Anyone can use S. It's not a big deal. But just to stay consistent, that's what I did. All right, so this is like pretty crazy that this is possible in TypeScript. So we're taking in some value that's written in binary, and we're returning back the actual number value. I am very excited to see this one. So how would you go about it? Like from a high, let's start here. Like from a high level, how do you approach this kind of thing?
I think we should be able to essentially iterate over the numbers and do a reduce operation. Adding 1 or 0 and then
like doubling or something?
Doubling the accumulator and moving on to the next character.
Okay.
Or next bit.
Cool.
Yeah, I think that should probably work. So yeah, what you said, that's we have a string. And yeah,
can we make like a counter or something? Yeah. All right. I'm with you so far.
Number.
Oh, okay. You have a number. All right.
That's we're going to return at the end. Yeah, this is a placeholder.
Oh, all right, all right.
Number.
Oh, we're gonna do it. Are you gonna do this again? We're gonna do it all in the. You think you can do it all inside here?
Yeah. I think it's.
I'm here for it. I'm very excited. You have a very different approach to these kinds of things. I really like seeing your solutions.
Yeah, I picked this up making PRs to a cool type utilities library called HKT toolbar. No.
Toolbelt. Yeah. Higher kind of types toolbelt. Yeah. I always think it's toolbox or something like that, but yeah, Matt has have you? Well, anyway, this is another aside, but he's been on the challenges here. It's been pretty fun.
Yep, and yeah, basically learned this approach from him, looking at his code. I really like it. It enables you to persist values across recursive calls. You can just add in one-off helper functions in here if you need to. And it's certainly much more readable than like a bunch of nested ternary statements. These more harder challenges tend to turn out to be. So yeah, I'm gonna initialize.
And I said Matt. I should say Mike. Mike Potat, I think is how you say his last name. I was thinking of Matt Pocock. Anywho, both TypeScript wizards.
So I need to be able to extract the first bit, the largest bit, most significant bit, I guess.
Most significant bit, MSB. Okay. I'm with you.
See how we could achieve that.
You can infer in there? Or are you going to put an extend somewhere in front of this?
Oh, yeah, we could actually start with finding a digit type. But yeah, I think
I'll do it for you. You want it just like 0 through 9?
Yeah, that would actually be useful.
Put me to work over here. 0, 1. Look at that. We're in the future. We're both coding on the same problem at the same time. 6, 7, 8. If I could type, that would be great. 8, 9. Nope. There we go. All right, we're off the screen here. Let me. Okay, B or 0, all right. Most significant bit, all right.
Probably get away with this.
String, okay, yeah, because we don't actually need it.
Then next step.
Oh, digit is just 0 or 1 in this case, isn't it? Or do we need all the numbers?
Oh yeah, we're doing binaries, so
Oh,
yeah, we don't
okay.
really need all the numbers.
So,
Sorry for putting it.
that's okay. That's okay. We can just put it right there. All right. It's all good. It's all part of the process, we should say.
For this, we're essentially going to do the exact same thing as above, but this time we don't need to infer. We know that MSB is the first bit there. So this is true. We're going to return our rest. So we're just we're shifting off the first character or bit in the input. And that's what we're going to use to iterate on in the next recursive call.
Okay.
And then we need to do the two operations. We need to add and then double or XOR. This time we're going to need to return number. What I want to do here is add the current bits, most significant bits, to accumulator, but we'll need to do an implementation of add for that.
Okay.
All we really need to do is that.
It happened to you. I wish there was a way to turn that off. Like, I don't want these big, long, esoteric node APIs to be auto-completed.
Yeah.
But, oh well.
I agree.
Repeat. Let's see.
Yeah.
Do you have that repeat? Can you paste it in here from a previous? Because we did. It's like the same one we did a minute ago, right? Which one was that? Fill or number range?
Yeah, number range.
We could probably come up with it again, but do you have it around? There. Oh, okay, cool. I'll format it for you while we're.
Push there.
Yeah, actually, you keep going on that. I'll talk about repeat for a second, just so everyone's on the same page. It's pretty straightforward. So we have a number. We have that's n. Then we have t, which is like a value that we want to kind of fill into the array. It's kind of like fill, actually. There's a TypeScript type challenge called fill, and this is basically the solution. I think actually this is almost exactly the solution. And then we have m, which is like an accumulator. And so we're checking the length and seeing if the length of n extends n. So actually, I'll just say it's hard to hear m versus n on the. Ooh, what's going on here? My editor is fighting with me. M. Great. No, it won't let me rename it. ACC. Boom. Okay. So we're seeing if the accumulator extends n, return it. Otherwise, keep recursing. And what we pass in, of course, the original, but we pass in t, which is the value we want to throw into the array. And then this accumulator gets built up. So that's how repeat comes. Okay. So I'm back with you here. Whoa. A lot happened. So let's see. So we have.
When using the use of repeats.
Repeat. Okay. And you're intersecting with number to force it to be a number. Is that right?
Mm-hmm. Yep.
Okay.
Otherwise, it gets weird sometimes. Yeah.
Okay. Okay. And then. All right. I'm lost. Help me out here. Walk me through it.
So this is just a tuple with filled with 2 times XOR nulls. So what we get left shift
That's
here
like the
is
doubling.
2 times XOR. Mm-hmm.
Okay. That makes sense.
Yeah, we can use this to implement a multiply in general, but right now we just need to double XOR, so that's all we're going to do. And so the base case here will make sense when I write out the recursive call.
Okay. L shift result.
You'll also notice that next here can be an empty string. That isn't necessary to specify, but it definitely makes things more readable.
Oh, okay, because it's ORed with. Why is it ORed with empty string? When does that come up? If you get to the end of the recursion?
Yeah.
Okay, to your base case.
So I'll just write that out right now. Yeah, next.
And then there is where we recurse passing in next. L shift is the same.
So, yeah, L shift right now, the doubled result is the next accumulator value, and next the input string with the current bit, the first bit,
I see.
out. That's going to be our next input string. So over the recursive calls, if we have like 11111 or 101 or 101,
Yep.
it's going to be.
It'll just keep chopping them off, and then eventually it gets down to nothing.
It's down to nothing. We get 0 as the base case. And next is nothing. Then we can just return XOR because there's no next bit. Or there are no more numbers to process. So just we don't even need to L shift. Just XOR value is what we're going to want to return.
Got you.
So yeah, this is a real base case. This is just for safety. Let me see if I can actually get rid of this. And
yeah, okay, you can get rid of it. Very, very interesting. I am super impressed. Okay. I'm impressed for a number of reasons, one of which is, I have to tell you, until today, this is a new style of writing TypeScript types. I didn't know that there was one waiting out there in the universe to find me, but it has. You have brought it to me. I think it's really interesting. Like, it's very, very interesting that you can do all of this just inside of the generic constraints. Like, all of the work is done inside here. Yeah, I don't know. I gotta wash this over my universe a little bit to get used to it. But well, let me show you some of the other things that I found for this. So I look around online always for other solutions. They're all gonna seem quite a lot less impressive, but here's one. So this uses the counter. I was telling you about this. When you're using counters in TypeScript and you're not actually extracting the values of the tuples for anything, you're just using their length. You can see count is never returned anywhere from this function. So you can pass in any value here. It could be a 1. Sometimes I've seen people do this. They'll put like a 1 there, or they'll do unknown or something. But I figure why not just make it fun and use a abacus? So that's what I do. So we extend T to grab out head and tail. Head is the first character, and tail is all the rest of the characters. If head extends 0, then we just want to add, we just want to keep going. Like, we don't want to actually increase the value. But if head doesn't extend 0, of course, the only thing it can be is 0 or 1. And we should probably define that somewhere, but there's not really a great way to do it in TypeScript because it's infinite. In any case, otherwise, we're going to add to the counter. And then in the end, we do count length. And again, look here, this is how the doubling is occurring. So we're doubling no matter what every time because we're going up the next section in the kind of, I'm sure there's a name for this in computer science, but like the next byte section of the binary, or the next, like, I don't know, what would be the name for that? Order of magnitude? Binary order of magnitude, I suppose. This one is very similar. We can switch the case, and instead of extends 0, we can do extends 1. It's exactly the same otherwise, but I just thought I would mention that I saw that people were doing that. Here's one that's kind of interesting. It uses double. So this is something that I think, did you call it double? Repeat. Okay. Yeah, this is generic. Like, it can be, you can repeat any number of times, but this one is just doubling. So we see here, it's kind of that part of the process that's been extracted out. So if increment extends 0, then you just double. Otherwise, you double and add 1. So kind of interesting. And we use it in the very same way down here. So this person just kind of extracted that out. And this one I'm trying to get better about putting people's names if I find unique solutions on GitHub. It's hard to do because I do look through a lot of solutions, but I'm not a TypeScript type challenges historian, and I don't want to credit someone for something if they're not like the first person to do it or something. I have no way to know. But this one looked pretty unique by Team Chong on GitHub, and this person's using a counter as well. They put the constraint inside here. I don't think strictly speaking, you don't need that constraint. Oh, we could do this. It doesn't have to be there, but I think it's nice to put it in there. And binary to decimal. is being recursed at this point. We're passing in the tail, and then the counter is, we double the counter. They put it on the beginning. You could put it on the end. We just need a comma there. Everything would still work if you put it on the end like the other ones do. And then same thing, if it extends 1, we put the abacus in there, otherwise nothing. And again, none of these people use the abacus. I just changed it because I have to format all of these anyway to fit on the screen for the challenges, and I thought it would be fun. So any thoughts on all of these? Do you like any one of these in particular?
They're all very concise. Yeah, I like them. I like the abacus too. I don't know if it's a great example or counterexample of clean code. I like it. Awesome.
Yeah, I mean, sometimes it's nice to see things that are short like this, but other times, like, it can be kind of beneficial to see like a longer, just like a thought process explained out. One way or the other, I really need to learn more about this style of doing things. I'll have to look at HKT toolbelt a little more closely. I've definitely seen it, but it's pretty interesting how much is possible to do just inside of the generic constraints. This has been an amazing experience seeing this. So I'm excited to see. We have a couple more. So I'm excited to see what we come up with next.